In this presentation, we'll look at the new security messages profile that can be used to assess the security of applications in QAC++ 3.2 and QAC 8.2. I have a simple project open here with mixed source, some C files and some C++ files. Let's go and have a look at the project properties and look at the message configuration. I've chosen the security profile. I can go and select that, and we can see that there's a number of other profiles here: effective C++, industrial sync C++, and critical. But the security messages are enabled the messages within the tools that relate to security issues. So let's select that, and if we just go and have a brief look at the messages, we can see which messages are enabled and which ones are disabled. So we can see the profile there. So let's save that. The other thing we've also done is turned on the data flow analysis in both QAC and QAC++. So let's analyze our project. So we see the analysis is quite quick, the files are quite small. So in the first file we have a issue here. We can see in the message pane down the bottom we have a definite computing of an invalid pointer value, and if we double click on that, it will show us where that issue occurs. This line here where we're adding the index to table. So table is a array, and we're creating a pointer into that array by using the offset index, and it's saying we're computing an invalid pointer value. We get a submessage telling us where table was declared, so we can go and have a look and see what type and size that array is, and then it goes on to tell us where the index was called from. So it was last seen there, to check that it's smaller than the table size, and if we click on the next one, it takes us to where that came from, and that was passed in from test2, and the value -1 was passed in. So although there's a check to see if the index is smaller than the size of the array, there's no check to make sure it's not negative, and it's this negative number that indexes one below the start of the array. So to make this secure, we should really check to make sure that the index isn't negative. In the next file is a C++ file. This is looking at the initialization order of member variables, and it's important to get this initialization order correct, because using uninitialized members to initialize other members will cause undefined behavior. So we have a class here, class C, and then another class D deriving from there, and in the constructor for D we have an initializer list. So we're initializing our member variables in class D first, and then we're initializing class C. And we have a message down here telling us that the initialization list is not ordered in the order of initialization. It says we expect to find a C at the beginning of the list, just there where the cursor is pointing to. If we didn't really understand what this message was about, we can click on the message help, and QAC++ will tell us what the problem is and why it's a problem, and there's some detailed help there, explanations and references. So as well as pointing out the issue, it gives us some ideas and hints on how to fix it. The next file looks at an issue that was found in the OpenSSH version 3.3 package. Here I'm provoking the issue by passing in an integer of a certain value that could possibly occur in the field. So in this function here, it makes a call to get packet int, and in this particular case I'm returning a number. I've suppressed the message that we would normally get here telling me there's a hard-coded number by using a comment-based suppression. So in here we check to see if the response is greater than 0, which it always will be because it's a unsigned number, though it could be 0. And then here we are allocating some memory by multiplying the size of the response by the size of a char. Now, on most systems, if we calculate this, the value will actually be 0. And in fact here, we are told that the value is 0 here. And this is because of the unsigned integer wraparound. So if we multiply this number by 4, we get back to 0. Hence, we allocate a buffer of 0, and then in our loop, we then proceed to fill that loop with data. So down here we're also told there's a wraparound in unsigned arithmetic, and then we're also told there's a definite dereference of an invalid pointer in the loop as we put data in the array that has 0 size. So this is a kind of issue that might not be able to be detected during dynamic testing, because the dynamic test cases may not include this particular value, whereas the static analysis data flow checker can check all sorts of values without actually having to run the function. In C++, we should use our classes to encapsulate data, and if data is encapsulated, it means that external functions and classes should not have write access to that data. They should go through a well-defined API. If we expose member data or certain data as non-const data, or enable people to make pointers or references from it, it opens the data up to manipulation by external forces. So let's have a look at the issues we've got here. If we have a look at the first issue, we have a function that is telling us the parameters passed by value. Not necessarily a bad thing, it depends on how big the data type is as to whether that's efficient or not. But the more important thing about this particular function is that we return a handle to the function parameter. And this is could be a problem if we pass a temporary value into the function. We'll return a handle to that temporary rather than a handle to a persistent object. So if we look at the usage down here, we'll see that we are doing such a thing. Notice that the issue is shown on the function that has the problem, because this is a potential bug. Depending on how this function is called, this may never actually become a bug, but it's the sort of thing that gets written into code and then used very infrequently, and perhaps later on several versions down the line, when suddenly code that was working now suddenly stops working. And it's very hard to try and find out where that issue is, especially if the code's been working for years. If we look further down, we have a class, and then we have another class that contains something that is private. So this data here is private to the class, and no one should be able to get access to that. However, we have a message here telling us that this function returns a non-constant handle to private or protected member data. That is, somebody calling this function here can create a reference to this private data. And by calling the function and assigning it, we can now modify the internal data. So we've broken the encapsulation that the private keyword has given us. The other thing we can do is to remove const qualification, so we can change things that should not be changeable. So in this particular class here, we have a const function, and we're told that our function here returns a non-const handle to data pointed to by a member. And this is our data here that is the problem. So by using this code here, we can in fact modify our data via our const handle. In the last file, we're going to look at some of the issues with inheritance and hierarchy. We have a couple of classes here, a class B and then a class D which inherits. And in the constructor for class B, we can call bfunc and qualify that call, and that will be okay. We know which function we're calling there. But if we call the same function without any qualification, it's a bit ambiguous as to which function will be called. And we get a message saying this virtual function is called in a constructor without a qualifier. And we might look at this and think, well, what does that really mean? So we can click on the help, and this will tell us what the issue is and how we can fix it, saying that we should always call them by their qualified name. And there's some code and some words to explain what the issue is, and it goes on to describe undefined behavior. So in this case, when we call func, it will always call bfunc, but never defunc. And that might have an effect on the program if the programmer intended to call defunc. There's also another issue here using casts, where we are using a cast in the constructor, and the sub-object has not been created yet. So this actually causes undefined behavior. Again, we can click on the help, and QAC++ will tell us what the issue is and give us some code example and go into some of the detail about why this is an issue and how it can be fixed. So here we've just had a look at some of the issues that can affect the security in programs, both in terms of things like buffer overrun, but also in terms of preventing undefined behavior and access to data that shouldn't be modified or should be private.